Okay, this is what we're gonna do. Bang. Okay, and then this is starting off with this 11. Who's 11? 7, 8, 9, 10. No. Oh, you are. Nice. Hope I remember you guys' names. All right, Matt, right? Okay. So this is what we're gonna do on the odds. Matt drew an easy one, but before we continue, sorry, Matt, to put the pressure on you. But um so I think I'm missing Friday. uh Taking another personal day, mental day after. I'm just kidding. But so I won't have the test Friday. There's really only one more new thing that I'm going to do tomorrow. Everything that I'm doing here today was on your quizzes and your ed puzzle, which I tried to get people that did not do that in Compass today, and some showed up, or if it wasn't up to what I thought it could have been, for you to finish that. I'll put those grades in as that. That's it. I'm done. Not waiting anymore. So that's what this is based off of. Tomorrow has some a little bit of new stuff, bit challenging, I guess you could call it. And then Thursday, Friday, probably review and review. And then that means the test will probably be Monday. And I won't be here on Friday for you. You should be able to handle it. Because actually, all of this is review. All right. That's what I'm trying to tell you at the beginning. Chapter 2 and 3 is really what's behind us. Those that will not do well on Monday still have not gotten the chapter 2 and 3 stuff. There's nothing we can do except keep trying today, Wednesday, Thursday, Friday, weekend to get these ratios down. I don't know. I don't know what else I can say. So, all right, Matt, here we go. What do we do first on this one? Our simple algebra skills here. Add 7, but then what else? What's 7 minus 5? If you go that, what's 7 minus 5? 2, okay. 2 sine x equals 2, and then what? And then just get used to this pen. I'm not going to throw a fit today. I'm going to be a grown-up today. Fine, pen. I love you. All right, what is 1 on the top? What letter? If you need to do this anymore, do you already know what the angle measure is? Okay, so if you don't know what the angle measure is, then that's why. What's the 1 on the bottom? I feel like I hear something. Somebody's phone out or something? What is it? Is that you? You're smiling.
It's not me, but I know what it is.
What is it?
There's a cat outside.
A cat? There's a cat outside. This is cat class. All right, what's the other one? Did someone meow or something? Was that a meow outside? What does that mean, x equals?
0.
You're right. Now do you know what it is? Okay, but it says up in the directions radians. That is actually the clue there. That does mean radians. Okay, good. You're done. If I have a fumble, whoever drops something there. The pencil. We were just talking about that. All right, and then because you watched the ed puzzle, you should know student number 2. What happens with this one? What am I going to do first, though? Jennifer, right? Is in radians? It's pi over 2. Huh?
Add the 1.
And then what?
Pi by 2.
Okay, so then what I have is sine squared of x equals 1/2. Then what? And then I think I was a big obnoxious jerk on this one, on the ed puzzle. What do I have to write on the right side? I'm going to try to be cryptic in the video. Plus or minus. What's the square root of 1?
1.
And then leave this. Because what kind of triangle is this? What is the reference angle? Then I'll get to your question. 45. Because it's plus minus, first of all, we're sign positive. What quadrants? I'm going to make you do this. Because you do have to eventually know this, but not in this question. And then we're sign negative. So you're in all 4 quadrants for 45. Quick question?
Just, can you scoot that over? Because when you take notes, I cannot.
You're saying I have a big fat head and it's in the way? I had to move. What are the 45s? Nope, this is in radians. Never put baby in a corner. Anyone know that movie?
Yeah.
Dirty Dancing. There you go. I've been shoved in the corner. What? Pi what? Pi over 4. What else? And then what else? And then what else? 8 pi over 4 is 2 pi. You went too far. Go to 8 pi over 4, then go backwards. 7 pi over 4. 9 pi over 4 is bigger. Actually, 9 pi over 4 is the same as pi over 4. Because that's an 8 pi over 4 plus another pi over 4. So 9 pi over 4. So deal with my pen. I'm doing just fine. I haven't thrown a fit yet. Mwah. Thank you, pen, for being here. 12. Did he just kiss the pen? All right, 12. What? Wait, you were right. It is him. You pointed at it. You're like, ding, 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 ding. Yes, you did. All right, Evan. Evan has no work shown on the sheet. He has all the answers already written. Is that true? Let me see your paper. I just saw a bunch of angle measures. So let's see if you got this one. You didn't. Nice. We're gonna save you on number 5 here. What do you do first? That you didn't show on your sheet? Divide by 3, and then what? I'll tell you what you did wrong. When you square root, what do you have to do? That's what you did wrong on your missing some answers. So humor us. Square root of. We got enough. Man, these orange sheets are popular. Very popular. You were moving. It's not you. You thought it was you, didn't you? What is this from? Oh wait. What does this mean? You just have to go down there now. I thought it was an attendance thing.
No.
That's where I'm getting confused. Gotcha. Okay. You got to go now. Yeah, you got to go now. It says immediately. The dean's office. Oh my goodness. You've been incarcerated. All right. So what's the square root of 4? Just humor me. And then what's the square root of 3? The square root of 3. But what didn't you not put in front? Plus or minus. Okay, what's your reference angle? Because you already know. But it's all of the 60s. So not to go too fast with this, but this is R and this is Y, and that should be over. Hi, Pen. All right. This is R, this is Y. That's enough. Y is root 3. Y is the reference angle side. So it's a 60. What are all the 60s? Tell me them.
60.
Nope, it's the radians. But you did write that.
2 pi thirds, 4 pi thirds over 3. 5 pi over 3.
This is getting worse, this pen. I was writing a little bit better last hour. Yeah. Oh, gosh. It's getting terrible. All right. I don't know. Okay, good. Then I just put this little weird one in there. And if, by the way, if it was like all answers, do I have student number 8 here? I do. All right. Dana in the back there. If it was all answers, these two are pi away and these two are pi away. So just to mention this, because it would happen on the test, if it was all answers, it'd be pi over 3 plus pi n, and then 2 pi over 3 plus pi n. But pi over 3 to 2 pi over 3 to 4 pi over 3 to 5 pi over 3 are not equally distant, so you can't just name one answer there. So you have to really think about how to name all answers. When they're 180 away or pi away, then you tie them with a pi n, right? We did that already. We did all answers stuff. Okay, what do we do? I forgot where we're at. What do we do first? This is a little weird one. This kind of threw off the 4th hour person. What do you think? Do I do what? Move it. Okay, how? What operation? Subtract it. This is like a variable. This is exactly what you do in this. This is an easier one, but students, when it's presented in front of them, they take a step back and like, what? You definitely don't divide by cosine. That would be totally bogus. And then what do we get on the left side? Yeah, they're just like terms. And then equals -1. What should I do next? So now that you did that one step, we get -1/2 over here. What letter over what letter? What does that mean y is, which is the reference angle? Not reference, it's the side that is opposite the reference angle. Oh, there we go. What's y then? This is what we do in our class. I mean, the other classes don't necessarily maybe go this far, but I'm trying to tell them this. What is the y side? And then what does that mean the reference angle is? That dictates the reference angle. That's why we kind of need to find that if we're gonna not recognize this. So again, I know where we're at. I know some of us can name the reference angle right now because they know sine of a 30 is a half, so cosine of a 60 is a half, right? That's where it starts with. That's what I do. I don't do all that y is root 3 thing. I just know sine of a 30 is a half, so cosine of a 60 is a half. And that really helps a lot of things. But it's a 60 ultimately. And where is cosine? Where is cosine negative? We should have this somewhere on our paper. Where's cosine negative? What quadrants? What are the 2 and 3 60s in radians? And? Correct. And then that's why I'm kind of verbalizing this out so that I'm testing you guys on your your ability to come up with these. And then you hear someone else, you're supposed to try to think of it yourself. You're involved in the notes, and trying to make your own notes and come up with your own ideas, kind of thing there. 18. I'm mad at you. We personally made videos for you last week. You were yelled at. I mean, you were mentioned. Let's say that. All right. Now I made you watch that Ed puzzle, right? Did you watch that today? Correct. This actually happened in there. I'm going to give you a hint. I'm pretty sure that we had because it was all about like the factoring skills in that one. Did it get you?
Yeah.
Let me see. Was blue good? I don't. Am I supposed to see that?
No, this is for a different class.
Well, you're supposed to check on it or no?
Yeah, for a different class though.
Well, no, but they want you to do it now.
Well, I can't do it today, so I'm good tomorrow. Because I can do it tomorrow.
Okay. Great. I gave you some time.
Yeah.
Good foilers are good what's?
Factoring.
But it's not really related to foiling. Factoring is also undistributing, which is 3 letters. Factoring. What are the 3 letters factoring?
What? 3 letters?
3 letters. Anyone know what I'm talking about? Raise your hand if you know what I'm talking about. Ashkenaz. You move that hand. No? Yes? Okay, don't say it. One of the letters, the middle letter is a C. Another letter is the 5th letter in the alphabet. 6th. That was bad.
F, C,
GCF. How do you guys not remember GCF? 5th letter is E. Isn't that right? I meant 6th letter. A, B, C, D, E, F. So GCF factoring.
Yes.
So you look at these 2 terms. What do they appear to have in common? That's the C.
Cosine.
So what can you do with the
So
cosine?
kick that
You
out.
can kick it out.
Yeah.
Violence. And then what's left over when you kick out that cosine?
Sin x minus 2 cosine x.
Oh no. This literally is a whole chunk taken away and taken
okay,
out.
okay.
So what is it?
Minus 3.
Yeah. You made a algebraic boo-boo there. The pen is. Don't do it. Don't do it, Mr. S. And then have we had this yet? No. Wait, yes. Oh, wait. No. No. No, we haven't had this yet. Okay, I'm going to write it, but then I'm going to erase it. What's it? You're getting all the letter questions. What's ZPP stand for? Now we have to use the ZPP thing. I actually almost gave away the last P is property. So the ZP property. Okay, the Z is a number. 0. And then the other P is what this represents. No, I just put a dot there. So what is that? What's a word that starts with P that represents that dot? Product property. The 0 product property says from the Ed puzzle, by the way, that if this times this equals 0, then this equals 0, or this equals 0. And by the way, that's not new at all, because I also taught that before. That was our second set of notes for this chapter. Right? I don't know, Mr. S. It was a 4-day weekend. I let everything out of my brain. I start at ground zero when I walk in. Hey, student number 18. What letter is this? And what letter is that?
S and R.
And then what does that mean? Y would have to equal. People often mess this one up.
0.
No, 0 squared plus 0 squared is not 1 squared.
1.
1. And then could it be plus or minus?
Yeah.
Yes, it could, because it doesn't affect this. And y could be plus or minus. So where do you have 0 for x and 1 for y? 0 for x and negative 1 for y on a coordinate plane. Where do you have 0 for x and 1 for y when you move on a coordinate plane, and 0 and negative 1?
It'd be the 90 degree and the 270.
But then it's radians. So what do we have?
Oh, pi over 2 and then 3 pi over 2.
There you go. And then what? That was me. I had those things invaded my brain at the same time. And then this one is actually good. Sine of x equals 3. 3 over 1. What's wrong? People are whispering. Something wrong? Huh? It does say degrees? Ah. Okay, so then you said 90 and what?
270.
My bad. That's my fault. I didn't know we switched sides. We're flying, actually. That's not too bad. All right, and then 3. What's 3? What letter? And what letter? Sine of x equals 3 over 1. What would 3 have to be because of sine? I hope you're crinkling your head or eyes for a reason, but what's 3 got to be? What
I
letter?
don't know.
Well, no, it's got to be what letter, though, because of sine. What sign? What letter over what letter?
Oh, okay.
Y. Y. And then what? Y over.
R.
Okay, is this why you're making a face? Is this possible? Can y be bigger than r? Can the opposite side be bigger than the hypotenuse? So this is not possible. I guess you could say no solution, but really it's, truthfully not possible to have a hypotenuse smaller than an opposite side, I guess is the best way. Okay, so that got the ball rolling. All right, number 6. Nice. All right, here we go. What do you think you do first?
Divide by 2.
There was no 2 on the other side, so that wouldn't really.
Divide by C.
Never.
Subtract.
Okay, so I'm glad that happened. You never divide by a variable. Imagine on the previous one, we divided both sides by cosine. It actually would work. If you divided by cosine, these would go away, then 0 over cosine is nothing. But you know what you lost? You lost all of these answers. You never divide by a variable when you're solving. Never. Same thing with this. Just regular grade school. Regular grade school question. X squared equals x. You cannot divide by both sides by x and just get x equals 1. Because you know what? You just lost this possible answer as well. So you need to subtract x, factor, 0 product property, and get that answer over on the right. Got it? So I'm glad that happened, because that is a common error. Often teach that way on purpose so that we don't have those errors happen. I'm happy that happened. What did you say last? You actually said it yourself. Subtract by how much? Subtract by both sides by what? I didn't hear a number. 2 secant. And then you're in the same position as the last question. Then what? I have a term and another term. What do those 2 terms have in common? Easy for me to say. So I take that out. And then what am I left with? Now you're going to be mad on this one, because my 4th hour person said the same thing you did. And ultimately, you would have gotten lucky. I still would have marked you wrong for dividing, because it's mathematically incorrect. But 0 product property, watch what happens with this. Secant of x equals 0. By the way, what's 0 over 1? What's 0? What letter? And then what letter is 1? What's wrong with that? Is that possible?
No.
So you would have gotten lucky by dividing because this still resulted in not a possibility. But if she would have done that in the previous one, mathematically it's incorrect and you would have lost a set of answers. So it's through luck that you would have been okay on dividing. Not here. That's Adam, right? Not here. 14. Is 14 not here? 14 sleeping. Wait, are you 14? Oh, nice. Okay, so I wanted you to do the next one. Okay, what do we got to do in the next zero product property? Here, I want to see how fast you can get this. What's cosecant of x equal to? Do a couple of steps. So do the zero product property, and then, huh? Oh, you add 2, but then how do you get rid of cosecant squared? Okay, and then what did you do wrong? Still, the most common thing when you square root both sides, people don't write this. Then that actually makes your life easy because, okay, I'm going to make you tell me this. Where's cosecant positive? What quadrants? Where's cosecant positive? Oh, you got to put an ASTC and know who cosecant's related to. Oh, to try 1 and 1 and 2. Where's cosecant? Get this one right now. Negative. So if it's positive 1 and 2, it's negative in 3 and 4. Cosecant's related to sine, ASTC. But really, you just have all, and then what's the reference angle? Hopefully you don't have to write anything down for this. This is a common ratio. So what are all the 45s in degrees? Well, one of them's 45. I'll do that one. What's the other ones? I find some people are having harder times with the degrees now. You're guessing on 135 and you're right. I'd run out of room here. 215. Oh, you're off. 225. I almost wrote that down too. You almost had me convinced. And then 3, say that thing you said before. 315. That's where the 15 comes into play. Oddly enough, 45. These are all how far away from each other? Every single one of them. I do want to cover this right now. How far is every single one of them away? Not 90, right? Am I wrong? They're 90 away. So you could name these all with one answer. 45 degrees plus 90 N. Do you understand that? So that's how when it comes down to how do I answer them all, you got to do a little bit more thinking and how to condense the answer in the most simple form possible. Sometimes you don't have the option, and it's a little bit easier. You just add 360 N. But sometimes you can condense it a little bit. 10. Who's that? Nice. Noah. All right. Oh, you got the tough one. Noah, I'll give you a hint. Chapter 5. I'll give you another hint. Chapter 5. I'm looking at that tangent squared. And then I'm thinking chapter 5, secant squared was something. Give you another hint. I have a shirt where there's these two scientists fighting over a C. Anyone know what shirt I'm talking about? Nobody knows that shirt? E equals MC squared. Who's that scientist? Who's that scientist? E equals MC squared. No one knows that scientist? These kids these days. Oh my gosh. Actually, my brain just died. What's his name? Einstein. Did you say Einstein?
The whole class said Einstein.
The whole class can't speak. Einstein. What are you like whispering it for? Who else uses C squared and they both are fighting over the C squared? My shirt? C squared's in the formula. I wear them on purpose because they're legendary right now. They're on Tactic or whatever. What other math formula ends with equals c squared for the love of dog in a public school. The Pythagorean theorem. So now back to this. There's a Pythagorean identity, secant squared with tangent squared in it. And that was the whole point of chapter 5. You could do substitutions. Do you remember, Noah, what secant squared equals? Not cotangent. We got this right here, so that's why the question was set up this way, right? Were you going to tell us? Or are you just stretching back there? Oh, just stretching. That's great. Oh, teachers always love that too. Or can I go to the bathroom? Right in the middle of a. Yes. Wait, are you going to ask to go to the bathroom now? Okay, what is it? It's 1 plus tangent squared. You're going to make a substitution and make this 1 plus tangent squared. Yeah, we made you memorize those. Those were not written on your formula sheet when it came to chapter 3. So at least it's got to come back a little bit. You seniors that forget everything. I really feel like that's a thing now. No remembrance. And then we'll go from it. Noah, go ahead. Okay, fine, you distribute. I already started. Son of a nutcracker. Oh, this. Don't do it. Don't do it. And then what, Noah? Well, I already did distribute. So now, is that good? Huh? But then this is the second time someone's do this. I also have a 2. So what do you think I do with this? Okay, so add the 3 and then what? Minus the 2, and what do you get over on the other side? No, you add the 3 and minus 2, and you get 1. And then what about this? What does this become? Sorry, that is scratchy looking, but it's 2 tangent squared plus another tangent squared. 3 tangent squared. And then what do you do? Divide by 3. And then what? So that's 1 over 3. And then I want you to simplify this. What is tan of x equal to? What do I have to write on the right side? Don't make the same mistake. I'm going to do this. Oh, that was not fair. Oh, no. Oh, I can't punch this anymore. I got my polyhedrons up here. Just knocked one down. Put this back here. Hold on. Well, I was shaky there. Did you see that? Oof. What'd you say? Plus minus good. Good. Square root of 1 is 1, and then we get this recognizable. What is this reference angle? Okay, and then I'm going to force you to answer this. Where's tangent positive, just to see if you got that right? Where's tangent positive? 1 and 3, and then where's it negative? And it's just to prove the point we have all 4 of them. So what are all 4 of the 30s? Because you did say, I got the first one. It's 30, then what? 150, what's next? 210, and then what's next? 330. Boom, bingo, got it. All right, so we're going to have that happen. All right, so you got to remember 1 plus tangent squared equals secant squared. 1 plus cotangent squared equals cosecant squared. Then the original was sine squared plus cosine squared equals 1. And we worked on deriving those and blah, blah, blah. And then who gets this? 2 of these. Nice. Good foilers, anyone? Kathleen, you got lucky. Matt, you got lucky. Oh my gosh, Ivo. Well, you miss all the time, so it's not about luck. And then 11. And Matt, your buddy Matt over here, and unbelievable. I don't know what this H is doing here. Anyway, what do you think you should do?
Drawing planes.
Do something, not nothing.
What can I even do?
We should do something.
Yeah. Try subtract. Okay. So then,
Why would you subtract cotangent squared when it's already a minus on it? You know what I mean? I mean, you're trying to they're not like terms, right? So you can't do anything with the fourth and the squared, right? So try something else. We have the time. Oh, you're getting a phone a friend. You guys don't even know what that show is. Distribute. What are we gonna distribute? Your friend just you called the wrong friend. This is fun. That's not true because 2 isn't a perfect square. And what someone told me last hour, which was a good start, they said they wanted to factor out a cotangent squared. But then is there a 15 product rule or is there a 0 product rule? 0 product property. So factoring out a cotangent squared doesn't get you anywhere. And that's not a difference of 2 squares. So I thought you could say subtract the 15. Now we're getting somewhere. Subtract, and it's unfair that I'm doing this to him, but I just want I want his brain to remember this. When you subtract 15, then you could do this. Good foilers? We're going to unfoil and think about foil as we factor this. This is what I tried to show you in August and September and October and November and December and January and February and March and, wait, what are we in right now? April! All right? What times what? This is first the foil. What times what equals 2 cotangent to the fourth? There's really only one possibility. You can put them on both sides, either side. It doesn't matter. Cotangent squared is one of the possibilities. What does that mean the other one has to be? It's funny, that's what last hour started with too. I always start with the other one first. Okay, this is the first of foil. What times what? Because this is why factoring goes wrong. You guys don't even understand this. And this is where the basis of what is being taught in previous years is going wrong. I really firmly believe that. To factor, you have to understand it's coming from the reverse of multiplying. So what times cotangent squared equals 2 cotangent to the fourth? So this is a 1. 1 times what equals 2? 2. And then cotangent squared times what equals cotangent to the fourth? That's why this should not be hard. But that's the problem. There's a disconnection for some reason that's making this factoring way too hard, and it's not. Next, that's first. Then I go to last. What are my possibilities for last? They have to equal -15. I'm really going to tell you it's what you think it's supposed to be. What equals -15? There's only 2 choices, but it's the more common one. 3 and 5, and one of them would have to be negative. And now what you have to do is maybe guess and check. And I don't think this ever happened when we were doing this. And I tried to enforce it. Not enforce it, that's not the right word, but I was trying to get you to understand. Now when you take your choices, this times this added to this times this, which is outer and inner for foil, should add up to be -1 cotangent squared. So now I want you to guess and check, and don't feel bad if you get it wrong. We'll check it. It is going to be 3 and 5, and one of them is going to be negative. So what goes first, the 3 or the 5? The 3 is negative, and you want it first? You want it in the first set of parentheses? I'm just double checking. Oh, okay, we'll do that. We'll do that. And then you want the 5 here? Now, what's 5 times 2? 10 cotangent squared. That's pretty large. And then -3 cotangent squared. What are those added together? 10 and -3. 7. Is that what you got as a middle term? No. So what do we want to do with these numbers? And actually, do I have to carry the negatives with them? Like flip the negatives as well? Yeah, I lost that there. So it is, I'll do green again just for, it was minus there. I was excited there. And I think your friend right by you there wanted you to put that 3 first as well because he caught it. But you missed it, but at least you got to, have the imagination there. So again, this is first, fourth, or 2 cotangent to the fourth. Sorry for that 4. This is still negative 3 times 5, which is negative 15. And now I do have a degree in the middle term. Negative 6 cotan squared plus a 5 cotan squared does equal negative 1 cotan squared. Now we'll go to the next person. Yeah, 2. Sorry, Jennifer, you'll end it off. What's cotan equal to? Let's be a cat student here and get this ultimately. Set this equal to 0. Do the square rooting. What do we get for that one? So if I set that equal to 0, I'd have to add 3, then square root. What's that cotan of x equal to? Oh, okay. I got to write out the zero product property. All right. I think it's the stress of being on task here. What do I do next? Add the 3. That's what I thought we could do, like without having to write it. And then once I add the 3, what do I do? Square root. Sorry, that x is getting all jacked up with my pen. And that's what I didn't want us to have to write. What is that? What do we got to do about that, though? Something's missing. Plus or minus, which you did get earlier there. And then where does that happen? What angle measures? You got all 4. That's what's great about the square rooting. You get all 4 quadrants, you barely have to think. You just got to know what is the reference angle and get all 4 of them. It is definitely not a 30 because this is over 1 and this is x over, yeah, it is a 30. I'm a complete total liar. All right, what are all the 30s, which we already listed before? And this is why I struggle with people still not being able to find these 30s, because we wrote these a million times in chapter 2 and chapter 3. And we just saw this. We saw these 4 answers like 2 answers ago. This is where I have an issue. I have a right to have an issue. And then everyone, what happens when you subtract 5, divide by 2, and then you square roots? What kind of answer is that? What is the square root of a negative, you seniors? What's the square root of a negative? Oh my, it's right here. I'm going to poke it right now. What is this? An I. It's an I number. Okay, what does that mean? What does that mean for an imaginary number, an I number? Is this going to result in a real solution here? So this is not real. This doesn't lead to anything. Okay, so it's just these 4 from the other half of that set of factors. Okay, and that's what happens here. So square root of a negative doesn't end up being